All right, we're going to catch back up where we were. So there was a mixture over here of the paper clips that were some were plastic and some were metal. And they're saying you can use a magnet to separate them pretty easily without having to pick them up with your fingers. All right, so let's look at what happens when we have dust and air in an air filter. That's a mixture.
Dust in air is a mixture. The air filter in a central heating or air conditioning system separates the dust from the air every day. As air flows through the filter traps many dust particles.
Okay, I have an example of that one right here. So in my mask, I have a filter, and what happens is, so I have makeup on my face, and makeup gets stopped on this side. And I don't know if you can see it, but it gets caught on this side. My makeup doesn't fall off of my face through the mask. The mask stops it, okay? But I could clean off the makeup, right, from this. Also, same with certain kinds of air. So if I sneezed into my mask, the mask would stop the sneeze particles from coming through. This mask acts like a filter, all right? An air filter does the same thing.
Ocean water is a solution that includes water, salt, and other things. Have you ever gone swimming in an ocean? Afterward, the sun evaporates the water on your arms and legs. Then you can feel and see the tiny salt crystals. Evaporation is one way to separate a mixture that is a solution.
So even solutions can be separated, but they have to go through certain processes. Let's look at this one, oil and vinegar.
Some mixtures, such as oil and water or oil and vinegar, separate by themselves. You can shake them to mix them, but they'll separate again if you leave the mixture alone.
Have you ever seen a thing of salad dressing? Now, ranch, it doesn't do this with, but like the oily salad dressings, like Italian dressing, you will notice if you have it in the refrigerator and you haven't used it in a while, you'll notice that the little gritty particles of the seasonings will go to the bottom and the oil will rise to the top. And that's why you have to shake it up before you pour it on your salad so that you can remix that mixture or solution. Oh, it said it was a mixture.
Some mixtures can be separated using water. These corks float, but the marbles sink, so they'll separate if you put them in water.
So just like we talked about magnets being a tool to separate parts of a mixture, sometimes scientists use water as a tool to separate parts of a mixture. Oh boy.
Have you ever sung songs around a campfire? As you watch the wood burning, you're watching a chemical change, or a change in one or more substances that forms new and different substances. Click the images to find out more about chemical changes.
So now we're moving on from physical changes and we're moving on to chemical changes. And that's kind of a bigger change. It's a serious change. It's one you can't go back on. All right? Burning is a chemical change. Let's look at the other ones.
Here, we see oxygen and iron combining to produce a new chemical substance called rust.
Oxygen in the
This
air.
is a chemical change. Rust has different properties than iron, and rust can't easily be changed back into an iron lock.
Okay, so the oxygen is in the air around it. Iron was the metal that was used to make the lock. When those two things combine, when the air is on that iron for a long time, it forms a new substance in a chemical change called rust. And you can't unrust something, not easily, in fact.
Photosynthesis is a chemical change. In the process of photosynthesis, plants use energy from the sun to change carbon dioxide and water into sugar and oxygen. The sugar and oxygen are very different from the original carbon dioxide and water.
Okay, and that is happening with my plants in my tower garden. I'm going to show some of you in the Zoom this morning. But here, let me make myself big so you can see. We go on our little field trip. Oh, it looks like I'm going really fast in the video. Okay, so in my tower garden, look at how much lettuce is growing. So the light, this is fake sunlight, so it acts like sunlight. The light and the water that comes up from the pump, that bottom part is full of water, and there's a pump that brings water to the plants. The light and the water work together to do a chemical change called photosynthesis, and that is what gives the plants some of their nutrients. I also put extra nutrients in the water because our plants are not planted in soil, and soil is where plants get some of their nutrients also. But that is a chemical change because you can't, like the stuff, the nutrients that the plant gets from the water and from the sun forms together to make that process happen. You can't undo that. There it is. Okay, let's move on.
Pancake batter undergoes a chemical change as it cooks. The pancakes look and smell very different from the batter, and they have different properties. You can't turn the cooked pancake back into batter.
Okay, even if you heated up the pancake in the microwave, would it melt back into pancake batter? Try it. Ask your parents, if your grown-ups at home, if you can try it. It won't work. In fact, I'm gonna do a lesson on this later on this week. I'll do a video from home, from my kitchen, and we'll experiment with that and see what happens. But making pancakes is a chemical change. You can't undo it.
You've learned a lot about physical and chemical changes.
Thanks.
Remember, a physical change does not result in a new substance being formed, but a chemical change does. Which of these pictures show physical changes and which show chemical changes? Drag each image to the correct box. Remember, you can roll over each image to find out what it is.
Okay, so this is a rusted nail. Do you see the rust on that nail? Do you remember what we talked about with rust? Rusting is a chemical change. You can't undo that. All right, what about this egg? We dropped it, it broke, and the egg came out from the inside of the shell. Did that change what it was? Is it a different thing now? Nope, it's still an egg. I guess you could put it back together if you had some tape and maybe some really good glue. You could put the eggshell back together with the egg. You could scoop it up and put it inside. It wouldn't be easy, but you could do it. That is a physical change. Breaking something is a physical change. Okay, melting. Remember how we said if it's a changing state of matter, like melting or freezing, that is a physical change. All right, let's see what this one is. Cutting, okay? I think this reminds me of tearing our sticky note. If you cut something into smaller pieces, it's just smaller pieces of that thing. It hasn't changed what it is. It is a physical change. What about burning? Like burning wood or burning a marshmallow. You see that blackened stuff? That is a different thing than the marshmallow originally was. That is a chemical change. Okay? Cooking. When you cook something, it becomes something different. Now, it's still an egg, but the hard-boiled egg is chemically a little bit different than the raw
job.
egg.
Melting, breaking, or cutting an object does not make a new material, so these are physical changes. Cooking, burning, and rusting all produce new materials, so these are chemical changes. What could you use to separate each of the mixtures shown above? Mixtures can be separated in many ways, such as with a magnet, with a filter, or by evaporation. Drag each label to the mixture that item could help separate.
Okay, so I see here a whole bunch of, some things are magnetic and some things are not. Do you think you could separate those things with a magnet? You think that would pull out all the magnetic things? All right, look at this nasty, gross water. Is that safe to drink just like it is? No, it's full of dirt and probably other stuff. If you had a special water filter, do you think that would separate out the grossness from the clean water? I think so. And evaporation. So do you see how they've poured salt into this water and mixed it in to create a salt water? If you left that outside on a hot day, would the water evaporate and leave behind salt crystals? Yes, evaporation is a
Good
tool.
job. Each of these mixtures can be separated in a different way. If you pour the muddy water through a filter, you could separate out the dirt. You could pick up the steel screws and nails with a magnet to separate them from the plastic and non-steel pieces, and you could get the salt out of the water by evaporating the water.
Sorry.
A mixture is a combination of two or more different substances in which the substances keep their properties. Click the example that is not a mixture.
Okay. In the soil, I see different things here mixed in together to make the soil. There might be some compost, there might be some worms and grossness in there. So I think that's a mixture. They poured flour and sugar and mixed it together. That's a mixture. Okay. Lemonade. What's lemonade made out of? Lemons and water and sugar. And they stirred it all up to make a mixture. But if they left it outside on a hot day, I don't know. What about salt? Well, the salt is just one thing, right? I don't know if one thing can be a mixture.
You've got it.
Yep.
Salt is not a mixture. A mixture is a combination of different materials that have different properties. In a mixture, you could separate the materials from one another. Salt is not a mixture. It's just salt.
Just salt.
You've learned a lot about physical and chemical changes in mixtures.
Yes, we have.
Let's review the main ideas from the lesson. A physical change is one in which the form or shape of a substance changes, but the substance still has the same chemical
Melted
makeup.
ice cream is still
Tearing
ice cream.
paper and breaking an egg are examples of physical changes. So is water freezing. A physical change doesn't result in a different substance. When water turns to ice, it's still water. A chemical change is a change in one or more substances that forms new and different substances. Rusting and burning are examples of chemical changes. A mixture is a combination of two or more different substances in which none of the substances change. Trail mix and beach sand are both mixtures. A solution is a mixture that is the same throughout because all the parts are mixed evenly. Sugar dissolved in water is an example of a solution. Now that you have finished this lesson, if you wish, you can go back and review any part of the lesson again.
Okay, so in the past 2 days, because this lesson ended up taking 2 days, it was a little longer than I expected it to be, and I didn't want to overload you. All right, so the first day we went through the first half of this lesson, and now we finished this digital lesson. We have learned a lot about mixtures and solutions, and physical changes and chemical changes, right? What I want you to do is I want you to go look around your house and see what you can do to create a mixture, not a solution, a mixture of something that when you put it together, you could take it apart. Some examples might be you could mix some Legos with some stuffed animals in one on top of your bed. You could mix it all up, right? Take a picture of your mixture. You could try it with some sorts of food, okay? You could mix some flour or salt together and see how it becomes a mixture, but see how you can still see the difference between a grain of salt and a grain of flour. Maybe you want to mix two kinds of cereals together, all right? I want you to explore around your house, and I don't want you to do anything without your grown-ups' permission, all right? But I want you to create your own mixture, take a picture of it, and submit it here. Great job, guys.